In, all, any, exists, like, between, and. The usage in or not in. The usage of all cannot be used directly. It has to be used in combination of any other. That is less than all, greater than all, equal to all. Remember, there are two operators here, two characters, one character and one word, but there should not be any space in between. Next, any, less than any, greater than any, equal to any. Exists or not exists, like or not like, between and, not between and. Only in this place we can see spaces between the operators, between the words of an operator. But in case of greater than all, greater than any, equal to any, less than all, no space. But when we use between and, there is a space. And when we use not, definitely there will be a space after not. Now let us understand what is the actual meaning of this. It can be less than all, equal to all, greater than all, equal to all. What is the actual meaning of that? When we say less than all, then the meaning of this is less than all the given values. That means less than the given minimum value, less than the minimum value in the given values. When we say less than all of 1, 2, 3, less than all the three values, that means less than the smallest value, the minimum value on the given list. Greater than all, same, greater than all the values in the given list. Greater than all of 1 to 3, that means should be greater than 1, greater than 2 and greater than 3. That means greater than 3. So in that case we use greater than the maximum value or the highest value in the given list. Equal to all, it should be equal to all the given values. Equal to 1, equal to all of 1, 2, 3, equal to 1, equal to 2 and equal to 3 also. Next, any, less than any, greater than any, equal to any. Less than any means less than any of the given values. Less than 1 or less than 2 or less than 3. That means when we say less than any, that is less than the maximum value in the given list, the highest value in the given list. Greater than any, greater than any of the given values, greater than the minimum value in the given list. Next, equal to any is same as equal to any with space. So we can use space here. Less than any, less than all, greater than any, greater than all, equal to any, equal to all. In all these cases, space is allowed between the character and word. Equal to any of the given values. Equal to all of the given values, which is not true. Equal to 1 and equal to 2 and equal to 3, which cannot be true. Equal to 1 or equal to 2 or equal to 3. This could be possible. Now let us see the comparison. I am using both two sessions side by side or two screens side by side. Select star from EMP where salary in 3000, 6000, 3100. That means the equivalent of in is written here. That is salary equal to 3000 or 6000 or 3100. That is salary equal to 3000 or salary equal to 6000 or salary equal to 1100. Sorry, 3100. Now the result is exactly same in both the cases. That means this expression is exactly same as this expression. Right? So when we use in, that can be replaced with this one, or if you see this kind of expression, this can be used using in, so that the length of the query becomes smaller. Next, where salary not in 3000, 6000, 3100, not in 3000 and not in 6000 and not in 3100. Salary not equal to 3000, not equal to 6000, not equal to 3100. Both will produce the same result, 15 rows, same data as well. Next, another example where salary between 6000 and 1000. We need to remember one thing here. The values whatever we use with between operator, the values are inclusive. When we say between, this is a range of value between 6000 and 10,000. That means whatever the salary falling between 10,000, between 6,000 and 10,000, all those salaries will be displayed. Here the given values are included, including 6,000 and 10,000. If anybody is there with 6,000 or 10,000, those people will also be displayed here. Now this is exactly same as this query, where salary is greater than or equal to 6,000 and salary less than or equal to 10,000. So this query can be replaced using between operator like this. Both will produce the same result. And we do have backward compatibility in Oracle. Because of that reason, all the old features will still work in our latest versions. So this query will also work even though we are using old features. So because we have backward compatibility, we can use any of the old features also. Next, less than all, 3000, 4000, 5000. Less than all the three values, that is less than 3000 and salary less than 4000 and salary less than 5000. Both are producing the same result, one row. That means less than all the three values, that is less than the minimum value. In this minimum value is 3000, the value should be less than 3000. Okay, the difference between this example and this example is there is no space between less than and all, there is a space between less than and all. So both are valid, there is no restriction, we can leave the space here. Next, greater than all, greater than all the three values, greater than 3000 and greater than 4000 and greater than 5000. That means in simple terms, the value should be greater than the maximum value. Means above 5,000. Salary should be greater than 5,000 only. Less than any. Here we use or. Less than 3,000 or less than 4,000 or less than 5,000. So this is the expansion form of this query. Both will produce the same result. So any one should be true so that the result will become true. So if the value is less than 3,000 or 4,000 or 5,000, that means in simple terms the value should be less than the max value, which is 5,000. Below 5,000, whatever the values are there, all those values will be displayed. And below 3,000 also will be displayed. Since we don't have any value, it is not, it is displayed. 2,500, we do have one. Next, greater than any. Greater than any of the three values. It can be greater than 3,000, or it could be greater than 4,000, or it could be greater than 5,000. So now, since the value is greater than, if the value is greater than 3,000, all those values will be displayed in the result. If the value should be greater than 3,000. See, all the values are greater than 3,000 only. Nothing is less than 3,000 because it is greater than any of the three values, greater than the minimum value in simple terms. Equal to any. When we say any, we use or here. When we say equal to any, that is exactly same as in operator. And this in operator is exactly same as or like this. So that is why equal to any. Will be same as in, so it will produce either 3,000 or 6,000 or 3,100. If these three values are there, then only it will be displayed. A range of values will not be compared here. Either 3,000 or 6,000 or 3,100. Whichever the value is there, all those values will be displayed. All the three also. Equal to all is invalid query. That is equal to 3,000 and equal to 4,200 and equal to 4,800. One value cannot be same always. That is why it is invalid. Not equal to all. That is same as not in. That is same as not equal to with and. See, not equal to all, not in. Salary not equal to this and not equal to this and not equal to this. All the three produces the same result, 15 rows. So the query can be written either this way or this way or this way. All the three are same. There is no difference. Whichever we are comfortable, we can use it. Not equal to any. That is not equal to this or not equal to this or not equal to this. Both are producing 18 rows. Same result. So not equal to any is same as not equal to with or operator. Next we will see some of the invalid scenarios. So not less than all, invalid. Not sign and less than all, invalid. Not all, invalid. Not any, invalid. Between and operator. This will display a range of values. This can be used to compare with a range of values. Salary between 2,500 and 6,500. That means salary must be greater than or equal to 2500 and salary must be less than or equal to 6500. That means from 2500 to 6500, whatever the value is false under the salary column, all those records will be displayed. Here the given values 2500 and 6500 will also be considered to display in the result. These values are present in the table, those values will also be displayed. See, 6500 is displayed, 2500 is also displayed because they are present as a salary in the table, and in between all other values are displayed. So below 2500 will not be displayed, above 6500 will not be displayed. 6200 is the max, 2500 is the min. Wildcards. These are used with like operator. So we use like operator now. So to use like operator, we need to understand the functionality of wildcards because we need to use wildcards. In SQL, we have two wildcards, percentage and underscore. Underscore will match to one character, one underscore will match to exactly one character, it can be any character. One percentage will match to 0 or 1 or more number of characters. Now let us see the usage of like operator. Select star from EMP where ename like k%. First character is k, after that there can be 0 or 1 or more number of characters. Means we need to display the records from EMP table where ename starts with K, that is starts with capital K. All those names will be displayed. There are two. Select star from EMP where ename like percentage small y. That means the names which are ending with small y. See here, Shelly and Kimberly. Last character is y. Percentage can match to anything, 0 also. That means if only small y is there, that is also valid here. In our earlier example, if the name of an employee is only K, capital K, that will also be displayed in the result because percentage can match to 0 values also. Next, percentage A percentage. So what does it mean? One percentage will match to any number of characters. So it has A. Before A there can be any number of characters. After A there can be any number of characters, or it could be only A also. So that means wherever A is present in employee names, all those names we want to display. Means the employee names that contain small a as their name, anywhere in the name, beginning, ending, middle, anywhere. Now capital A, Alana. Before also Alana came because it is small a. Small a also they have. Capital A. In this example we used capital A, we did not include small a. So the result with capital A is only displayed here. Next example, percentage EN, again on ename only. The names which are ending with EN, there are two, Stephen and Karen. Percentage LL, the name should contain double L's anywhere. Shelley, William, Wally. E name like underscore I percentage. That means first character can be anything. One underscore will match to one character. It could be anything. And then I. Second character is I. First could be anything. Second should be I. After that, there can be any number of characters. It can be 0 also. That means if the name is exactly having 2 characters, out of 2, if the second character is I, then that name is also eligible here. Second character is I. See, in all these cases, second character is I. After that, there can be any number of characters. All those names will be displayed. I think there are 2 underscores here. 1, 2 underscores, E percentage. First 2 characters can be anything. Third character is E. After that, any number. Third character must be E. 1, 2, 3. After that, there can be any number of characters. Percentage E underscore. Underscore is at the end. So, last character can be anything. Last but one character. Second position from the last. There could be E. Before that, any number of characters. If name is having only 2 characters and in that first character is E, that is also valid. See, in these examples, last but one character is E. All the examples. Next operator, exists. We know that this operator is used to check for the existence of a value, to check for the boolean true or false, whether the query returns true or false. See, select star from EMP where exists. We are using a subquery here in the where clause. Select sal from EMP where sal equal to 2500. In the outer part, we have select star from EMP where exists. That means if the subquery returns any result, then it becomes true. If this is true, display the result of outer query. If this returns null, then the subquery returns false. Means subquery is not returning any data, that means it becomes false. So the outer query will not return any data. Select sal from EMP where salary equal to 2500. We have salary 2000 in the table. So the subquery returns a value. It will return true. It become true. Since it is true, the result of select star from EMP, because we don't have anything else apart from this in the outer query. So all the records from EMP table will be displayed, which is 18 at present. Next, see here, we want to know whether it is true or false. That's all. We need not fetch the exact value. Salary 2500 is there or not? Yes or no? We don't want the actual 2500 here. We can simply select 1, 2, 3. Select 1 from EMP where salary equal to 2500. If salary 2500 is there or not, first check it. If it is there, return this value. If it is 1, directly it will return. If we use database column, again it has to go to the database First it will go to the database, check 2500 is there or not. If it is there, fetch that value into the buffer and then display. But in the second case, no fetching, display 1 because it's a fixed value. That fetching part of the database columns value will be minimized. That will be a performance gain for us. That is why we always prefer exists operator instead of in operator. So in it will exactly check for the existence of the value. So it has to fetch the database columns value. But in case of exists, we don't want. We want to know whether it is true or false. So fetching of the database columns value is not required. So performance will be increased because one step is minimized here. Another example, instead of 1 we are selecting 0. Means whether it will give 0 or null. Null means false, 0 means true. Still it is giving 18 rows. It is 14 here. I think data is changed. Yes, this data is different and this data is different. Okay, I think this is different schema, that is why we see different data here. Otherwise we get the same amount of data. So now we have the same data if it is 0 also. Now let us see another example. Select sal from EMP where salary equal to 5000. I think okay, in this data 5000 salary is not present. Since it is not present, this will not give any data, that is this query is not giving any data, so it becomes false. Since it is false, the outer query will not produce any result. Another example, instead of database column we are using select 1. Result will be same. Now 2500 we are checking whether 2500 is there or not. 2500 is present. If the subquery returns a value, then it becomes true. If it is true, execute the outer query. In outer query what is there? Select star from EMP where department number equal to 90. The result of the outer query will be displayed. Before we do not have any where clause, another conditional clauses in the where clause, but here we do have one condition now. If this is present, display this data. Select star from EMP where department number equal to 90. So that is what is this one. So 2500 is not present in department number 90, that is present in department number 30. So we don't need output of this one. We want to know whether it is present or not, yes or no. If it is present, then it becomes true, then the result from the outer query. So our aim is display the output of outer query. If the subquery, if this is true, that means we want to fetch data from a table if salary 2500 is present. If salary 2500 is not present, don't display the data from that. In that type of situations, we use exists operator. Not exists, the reverse. This is true. Not exists. Not exists is true if the data is not there in this. Since data is there, this is false. So it is not returning anything. Use the same example. Not exists. We will check phi not 1. We use 1. Select 1 from EMP where salary equal to phi not 1. Phi not 1 is not present here. Since phi not 1 is not present, this become false. But we used a not exists. If this is false, negation of not is true. If this is true, display the data of this one. Yes, the same data will be displayed. This is how we use exists operator or not exists operator. Next, move on to logical operators.